we are going to look at finding the volume of rectangular prisms. So remember that the volume is the space that is occupied by a solid. So if you remember, area was the space occupied by a two-dimensional figure, right? We can then just apply that. So now, rather than looking at a two-dimensional figure, we're looking at a three-dimensional solid. So for example, if you have a box from Amazon perhaps, right? And you want to know how much space is inside that box, we would be finding the volume. Now the formula to find our volume is length times width times height. Okay, we could also write this as base, the area of the base, times the height. Right? So we know that if we took, okay, here's our area if we're looking at the base, and then we're just going to multiply that by our height, we would be able to see what our total volume is. Right? So for example, if you had an area, let's say this was 10 by 5, you'd have an area for that base of 50, let's say square centimeters. And then if we were to have a height, let's say of 4 centimeters, right, we could apply, okay, it's a 50 square centimeter area over 4 total centimeters. So 50 times 4, we would have that volume of 200 cubic centimeters. Just like we talked about before, if centimeters times centimeters can be written as centimeters squared, then centimeters times centimeters times centimeters can be written as centimeters cubed. And again, this should make some sense because a cube is three-dimensional. So we can see that connection to using cubic units here. So again, our formula to find the volume is simply the length times the width times the height. So let's practice this a little bit. So here we've got this green rectangular prism. We have a length of 7/8, a width of 1/2, and a height of 5/8. So again, our formula is length times width times height. So we can substitute 7/8 for the length, and 1/2 for the width, and 5/8 for the height. Now we can go ahead and multiply. So we've got in our numerator 7 times 1 times 5 would be 35. And 8 times 2 times 8 would be, we'd have 16 times 8. Which would be 128. And so the volume here would be 35 over 128 cubic meters. All right, let's look over here at our next one. So this time we have a length of 3/2, a width of 3/2, and a height of 3/2. So we can see that this one's a cube. And again, our volume will be length times width times height. So that'll be 3/2 times 3/2 times 3/2. And again, multiplying fractions, we can just multiply our numerators and multiply our denominators. So 3 times 3 times 3 would be 9 times 3, which is 27. And 2 times 2 times 2 would be 4 times 2, which is 8. So we'd have 27/8, which we could rewrite as a mixed number, which would be 3 and 3/8. So our volume here is 3 and 3/8 cubic inches. All right, now we've got this computer tower here, and this time we're given the volume, and we're given the length and the width, and we need to find the height. So again, we can use our volume formula, V equals length times width times height, and substitute the values that we know. So we know our volume in this case is 1,792. We know the length is 16. The width is 7, and we do not know the height. So again, our goal is to isolate h so that we can solve. So the first thing we can do is multiply 16 and 7 to simplify that. So 16 times 7 is 112. So now we know that 1,792 equals 112h. And so in order to isolate h, we need to divide both sides by 112. That will give us h equals, and we need to solve here. So 112 goes into 179 once. And it'll go into 672 6 times. So we get 16. So our missing height here is 16 inches. And if we were to go back and check our answer, 16 times 7 times 16 should equal 1,792. So let's just check. So our volume is equal to length times width times height. So we have volume is 1,792, and we have 16 times 16 times 7. So let's start with 16 times 16. We get 256, and then we can multiply 256 times 7, and hopefully that will equal 1,792. And it does. 1,792 equals 1,792. So we have checked our answer, and we know that the height is indeed 16 inches.